Welcome to The Explainer. Today, we're diving deep into something absolutely fundamental: how to secure the very core of your network. We're talking about your routers.
So let's start with a really simple way to think about this. An unsecured router? It's basically the unlocked front door to your entire digital house. It's the one place where all of your most valuable data has to pass through.
And here's the scary part. When a router isn't protected, that open door gives an attacker the keys to the kingdom. They can exploit those weaknesses and get right in.
And the results of that? Well, they can be pretty catastrophic. We're talking about things like man-in-the-middle attacks, where they intercept all your traffic, or a denial-of-service attack that just knocks you completely offline. They could even create a network black hole where your data just disappears.
So it's pretty clear what our first job is, right? We have got to lock that front door. In the world of network security, we call this essential first step device hardening.
So what is hardening? Really, it just means you're systematically going through the device and reducing its attack surface. You're turning off services you don't need, locking down access. Basically, you're making the target as small as you possibly can. Because, a smaller target is a lot harder to hit.
Now, that might sound like a whole lot of tedious manual work. But here's the cool part. Cisco IOS has this incredibly powerful feature called Auto Secure. It boils down this whole lockdown process into a single command that just goes and applies a ton of security best practices for you.
So what is this command actually doing under the hood? Well, it's a full-on security sweep. First, it disables a bunch of old, risky services that are often on by default, but you probably don't need. Then, it enables critical security settings, like password encryption. And finally, it secures all the different ways you might access the router. It is a fantastic first step.
And that brings us to a really key part of hardening. How are you actually managing the device? You could do it in-band, mixing your management traffic with all the regular user data. But a much better way is to set up a separate, out-of-band network. This is huge, because it means you'll have a secure lifeline to your router even if the main network is down.
Okay, so the door is locked. That's layer 1. Now for layer 2, we need to secure the actual conversations happening inside. We need to make absolutely sure our routers are only talking to other routers they trust and not some imposter. Because if you don't have this layer, an attacker can just pretend to be one of your legitimate routers. And if they pull that off, they can start feeding your network bad information, injecting fake routes that send your data wherever they want it to go.
And the way we prevent this is with something called routing protocol authentication. Honestly, the best way to think about it is like a secret handshake. It forces every router to prove its identity before it's allowed to share any information with another router.
So how does this secret handshake actually work? While the routers use a shared secret key to create a unique digital signature, we call it a hash, for every single update. The router on the other end does the exact same calculation. If those signatures match up perfectly, the update is trusted. If they don't, it's immediately thrown out. No questions asked. Now, different routing protocols have different ways of doing this. You'll see MD5 as an option a lot, but you should know that modern algorithms like SHA-256 are way stronger and always the better choice if you have it. They just create a much more secure signature. All right, we've locked the door and we've established a secret handshake. That's great. But for real, long-term security, you need one more thing. You need a robust monitoring system. You need digital watchtowers keeping an eye on everything 24/7.
So first up in our monitoring toolkit is syslog. Think of this as the master event log for your entire network. It collects messages from all your devices, creating this detailed moment-by-moment record of exactly what happened. Every login, every change, every little thing.
Next up is NTP, and trust me, this one is absolutely critical. I mean, what good is a list of events if you don't know exactly when they happened? NTP is the timekeeper. It synchronizes the clocks on every single device so you can build a perfect timeline and see the full picture of any incident.
And finally, there's SNMP. This is your real-time status monitor. It's what lets you look at a device and ask, how are you doing right now? You can check its health, its performance, its CPU usage, all the vital statistics you need to know. Now, SNMP has been around for a while, and it's really evolved. The older versions, they use these simple unencrypted passwords called community strings. But the modern standard, SNMP v3, is a whole different ballgame. It gives you message integrity, proper authentication, and full-blown encryption.
And this right here is why that matters so much. Powerful, modern management tools, like Cisco's Identity Services Engine, they require the security of SNMP v3 to do their job. You just can't build a secure management system on top of an insecure protocol. It's that simple.
Okay, so let's pull all of this together. Let's see how all these pieces fit into a single, comprehensive strategy, a layered defense. So here's the big takeaway. Real router security isn't about any one single thing. It's a defense made of layers. First, you harden the device itself to shrink the target. Second, you authenticate its conversations so it only talks to friends. And third, you monitor everything constantly so you're never in the dark.
Which brings us to our final thought. Putting these layers in place is a massive step forward. Your front door is locked. But security isn't something you set and forget. It's a continuous process. You always have to be watching who's knocking.